This is section 1 PowerPoint. We will start at chapter 1 and proceed through chapters 2 and 3. Chapter 1 is Instrumentation Overview. In this chapter, we'll define the process control instrumentation, identify sources of training for instrumentation, and identify common industrial and industry and standards organizations. First trend is replacement of simple, repairable mechanical devices by sophisticated electronic or digital systems. On the left, we have a pneumatic controller normally used on a boiler to sense pressure, temperature, flow, that sort of thing. On the right, we have what we know as a PLC, which can replace this and a lot more devices like it electronically. A boiler operator or stationary engineer is responsible for maintaining the operation of complex industrial equipment. What you're seeing here is the backside of a boiler. It is monitoring the gases that are leaving the boiler, and they are leaving at 350 degrees. He is using a temperature probe to verify this temperature is correct. Technicians working in the HVAC field are often responsible for installing and troubleshooting systems that include pressure, temperature, flow, humidity. Keeps working as designed. Once again, here's another HVAC technician. He is monitoring the air coming out of the system. Think of it as in our shop, if we are having a problem keeping the temperature in the correct range, one thing to look at is how hot is the air coming out, and is that what the controller is actually seeing, or is the controller seeing a different temperature? Just a couple of years ago, we had a hard time in the winter with our shop being warm enough. Turned out that the sensor was seeing that it was putting out 98 degree air, when actually it was putting out 40 degree air. So that's just another thing that we have to verify. So you as an electrician, you may be asked upon to install or configure instruments in the field. We will be doing this in our shop. We will be connecting thermocouples. We will be connecting pressure sensors. If you think back to PLCs when we learned about wiring diagrams, we will be doing more diagnosing through wiring diagrams. A modern transmitter receives inputs from several types of instruments and sends signals in both digital and analog format. So think of this as a junction. So if we have several different pressure sensors or temperature sensors, they can come into one enclosure, and then we run one, Ethernet or device net, some sort of communications path back to the PLC or to the temperature controller. Organizations can be broadly classified as government agencies, standards, technical societies, private organizations, and trade associations. So these are just some of the organizations that have a hand in the instrumentation field. Most of them you don't have to really worry about. A few of note: EPA, because instrumentation has to deal with water, most notably wastewater. That's where we run into the EPA. The CSA and the IEEE and ISA. These are programming, automation, controls engineers societies. As we look down, NEMA you should have heard about before. Chapter 2 is fundamentals of process control. We're going to define the process control and identify the kinds of variables found in process control, difference between process automation and factory automation, identify the control elements of a process control system and explain their functions. Static and dynamic performance characteristics of a control system. You should know what these two words mean by now. Define a control loop and identify the types of control loops, and define a control strategy. Compare the common types of control strategies. So if we think to a boiler, if you don't know how a boiler works, a boiler has water that comes in, there's fuel. When the right amount of draft or air is present and there is a need, the fuel will ignite, causing a flame to produce steam. As long as there's enough water to safely create steam without overheating the boiler, it will continue to work. A low water fuel cutoff is the level measuring device that shuts the boiler down. So what you have here is you have a sight glass that you can see, the operator can see. Inside this, if the fuel drop, or if the water drops below, there's a mechanical switch in there that will close, and it will cut the fuel, most notably propane, off to the boiler, and the boiler will shut down because then there's not enough water in here. And if you pour hot water on, or cold water on hot steel, it expands very, very fast. And so if you do that in a huge boiler, you're going to blow up. Process automation refers to process involving batch, continuous flow, liquids, gases, and bulk solids. So basically what we're talking about here is process automation, liquids, gases, chemical reactions, outdoor facilities and high ambient temperatures, so on and so forth. We'll dive more into the process automation in later chapters. Factory automation refers to processes usually involving the flow of product. So instead of worrying about the steam or the hydraulics or the water or the air, in factory automation we're more worried about the conveyors, the batching, the robotics part of it. Process control system uses primary element, a control element, and a final element. So in here, this is a simple piping and instrumentation diagram. So we have our primary element, that's what we're going to control. So our primary element would be this coming out right here, whatever this is. A control element, which is our steam that's coming in here, and our final element, which is what's coming out. Static characteristics are characteristics of an element that describe the operation of the element at steady state conditions when the process is not changing. Dynamic, as the process changes, the dynamic characteristics change as well. Hysteresis. A control loop is a control system in which information is transferred from primary element to the controller, from the controller to the final element, and from the final element to the process. So here is a closed loop system. So very simple example. We have our thermostat and a vent or a radiator, much like you'd see in an old school. So what it does is we set our temperature. It opens and closes the amount of steam that comes in here to raise that temperature up. This temperature says yes or no, and we just keep looping back and back and back. Open loop means that I'm just supplying this to another process on down the stream. So we have chilled water return, so it came from the process, it's probably warmed up or has been used in the process. So what we're going to do is we're going to run it across a coil here, get the pressure and the temperature to go down based upon this compressor and this exhaust fan. So we're going to get it to go down and send on. On-off control, so you can think of this as your air compressors. So we have a set point, so 120 psi, so we can go over and under or so on. They have this is a way that they're using is the heating and air conditioning. So here's my 72 degree set point. We may get up to 74 and we get down to 73, and it bounces back and forth. Proportional control, here's your tank. So we've got a liquid float, so it opens and closes this based upon how much below or how much above the midpoint it is. And proportional on-off time, that has a predetermined output period during which the output is held closed for the variable portion of the output period. Okay, so we've learned about the different ways. We've learned what instrumentation is, and we've learned about some of the different control strategies. Let's put them into a diagram. So piping and instrumentation diagrams, symbol and numbering, recirculation tanks, temperature control. These are things we're going to touch on real fast. Define a piping and instrumentation diagram and explain its function. Describe the means of identifying instruments on a piping and instrumentation diagram. So the letters of the alphabet are assigned common meanings and combined to show multiple pieces of equipment. So if we looked at just these LT, LT, LC, you would look at them and you'd be like, what? This doesn't make any sense. We're going to break it down very simply and be able to diagnose a big chunk of information, much like when you're in hydraulics and pneumatics and you look at a very complex symbol. There's little bits and pieces of that symbol that you can break apart and actually figure the symbol out without looking at the whole thing. So the first thing is we're going to look at that first level, and that's our measured variable. Okay, so it will tell us, okay, we're going to measure level or pressure or temperature or flow, something like that, and each letter just stands for, hey, this is what we're measuring. The second is functional identifier. Okay, it can be an indicator, it can be a transmitter, it can be a recorder. Okay, so we're measuring level, and now we're going to measure it and do what? Okay, in this case, it happens to be a level transmitter, T for transmitter. So we're going to take the information that we get from our level, about our level, and we're going to transmit it to something, some other controller or a display, something that's going to use this. And loop 8, or the 08, so that's our loop number. What is it connected to? What does it affect? So if I excuse me, if I have a level transmitter that is actually connected to a level display, which actually connects back to a valve, they would all be on loop 8. So you'd see level transmitter, level recorder 08, and level valve or push valve 08. Okay, so that is level transmitter loop 8. Okay, if we continue on down, here's some extra ones. Level indicating controller, level recording controller, level indicator, level transmitter, level valve. All these, once you know the letters and what they actually stand for, you can break them all down real simple. A drawing includes many standard symbols and labels. Throughout this chapter and throughout this section, this is going to be the main part of the section, is being able to decipher through a diagram just like this. A detailed view of the recirculation tank drawing shows how instruments are related to the pumping system. So we've got our recirculation tank, so water coming back from a system needing to cool down, or like in a hydraulic system, their tank is actually a recirculation tank, because fluid will come in, it will go through a set of baffles to cool down, drop sediment, and then be returned back. So you can see, okay, we're coming back in here, and then we're coming back out. We have a strainer, okay, and you can see that there's several different identifiers along the way. That obviously is a pump, so we come out to our pump, and if an FE right here, which is connected on down, it comes up. There's a little bow tie, that's just a valve. Go through a filter, and so on. So we can start to see, just by looking at it, we can start to break it down. Detailed view of the controls show how information is transferred from instruments to the final control. So we have a heat exchanger, so our fluid comes up, goes through a heat exchanger. Heat exchanger is just used to cool or heat fluids up. So in this case, we're supplying steam. So we come through here, we have a TV temperature valve comes in, and it goes into the heat exchanger. So our fluid comes up, goes through the heat exchanger, which is actually receiving steam. So we're heating up whatever this fluid is, and it comes up. You'll notice that it jumps over. It does not join. So we jump over, come up here to evaporated to DWG, fail closed valve. That must be our drain, our drain back. So we come up, we've got a valve here, we've got a valve here, we go through the heat exchanger, there's a couple, that's a 2-inch pipe, goes to a flexible coupling over to another valve, which is controlled. We have a TIC, temperature indicating controller. So here's a controller that's going to tell this valve yes or no to open based upon what's going on downstream.